Hi, I'm Chris Harrison, and I'm going to talk about Abracadabra, an input technique for very small mobile devices, ones too small for practical touchscreen use, and with limited room to accommodate physical buttons. Instead, we take interaction off of the device and into the unused surrounding area. This not only provides a larger area for input, but also reduces occlusion of the screen from fingers. We achieve this interaction by employing a 2-axis magnetometer operating behind the display, and a small magnet which is worn on the finger or potentially integrated into the tip of a stylus. This configuration provides a high accuracy and wireless means to interact with very small devices. Furthermore, magnets can penetrate occluding materials and never have to be recharged. I will now talk about some of the example interactions enabled by our technique. The first method, for which the magnetic sensors we use are particularly well suited, is rotational input. This, quite simply, calculates a bearing to the magnet on the finger. We use this functionality in two distinct ways. The first is to support angular buttons with fixed locations. The second way is to use rotation to navigate lists, clockwise to scroll down, counterclockwise to scroll up. Users can click by flicking their fingers vertically. This feature relies on the dipolar property of magnets. When a fingertip moves below the sensor plane, the magnetic field inverts. This flip is captured by the sensor and interpreted by our software as a click. As can be seen in our proof of concept audio player demo, bidirectional scrolling and clicking is sufficient to traverse hierarchical interfaces common in mobile devices. We also created a simple photo album browser that operates in much the same way. In this application, clicks are used to enter and exit albums. The second primary input method is pointer control. This is achieved by combining the angular position of the magnet with its relative magnetic field strength. Here, a user clicks on a series of abstract buttons laid out in space around the device. This fine granularity position control could enable devices with very small screens to support traditional user interfaces, those with, for example, hyperlinks, buttons, and sliders. Finally, gestures, both rotational and positional, offer an excellent way to trigger coarse actions. For example, a user could switch modes, answer an incoming phone call, or mute alerts with a particular motion.